Okay, we're going to look at how to write the equation in standard form of a circle that passes through these 3 points, -2, 3, 1, 5, and 2, -1. We're going to start by plotting those points, so that's what I have here for you. Here's -2, 3, here's 1, 5, and here's 2, -1. From geometry, we might recall that the perpendicular bisector of each chord will intersect to find the center. So if we draw the chord from -2, 3 to 1, 5, and from 1, 5 to 2, -1, their perpendicular bisectors will intersect at the circle. And one of the things that we need to write the equation of the circle is its center. Now, if we remember, these two lines, since they're perpendicular, what do we know about their slopes? Right, their slopes are the negative reciprocals of each other. So we're going to find the slope of this line, and I'm going to call this one line 1 so we can distinguish between this one and this one line 2. So if we do the slope of line 1, remember that the slope is y2 minus y1, so 5 minus 3, over x2 minus x1, which is 1 minus a -2. Okay, 5 minus 3 is 2, 1 minus a -2 is 3, so our slope of this one is 2/3. But the relationship between slopes and perpendicular lines is they are the opposite reciprocals of each other. So the slope of the perpendicular for this one is going to be the negative reciprocal, so the negative of 2 and the reciprocal, which would be the -3/2. Now we're going to repeat this process for line 2. So for the slope of line 2, we're going to take 5 minus a -1, which is going to give us 6, and 1 minus a 2, which is going to give us a -1. So the slope of line 2 is -6, but we want the slope of this perpendicular line, so we know that we need to do the opposite reciprocal, which would be 1/6. All right, so now we're going to use those, and we're going to use the fact that this is a perpendicular bisector. A bisector means to cut it in half. So this point right here is going to be the midpoint of this chord, and this point right here would be the midpoint of this chord. So we need to find the midpoints. In order to find the midpoints, remember that it's x1 plus x2 over 2 and y1 plus y2 over 2. All right, so we've calculated the midpoint here. 1 plus a -2 is -1 over 2. 5 plus 3 is 8 divided by 2 is 4. So that's the midpoint for line 1. And for line 2, we have 1 plus 2, which is 3 over 2. And 5 plus a -1, which is 4 divided by 2, which ends up giving us the point 2. Now that we have those two things, we have the slope and the point, the midpoint for each of these, we can write the equation of the line. And then what we're going to do is take those two equations and we're going to set them equal to each other. And that will give us the point of intersection. All right, so we're going to use this point and this slope for this first line, and we're going to use the y equals mx plus b to write the equation. We can also use y point slope form, which is y minus y1 equals m times x minus x1. but it seems like most of my students tend to like this way, so we're going to do this. So our y is 4. Our m was up here. It's a negative 3/2. Make sure you're using the perpendicular slope. My x is a negative 1/2. And I don't know what b is. I'm going to end up solving for b. I can go ahead and multiply these together, and I get 4 equals 3/4 plus b. I'm going to subtract 3/4 from both sides. And when doing so, I need to think of 4 as 16 over 4, so I've got common denominators. So when I subtract that, 16/4 minus 3/4 gives me 13/4. And that is my b. Now don't forget to go back and write your equation of your line. So y equals, we're going to use that slope of negative 3/2, x, and then plus my b, 13/4. We're going to repeat this process over here for line 2, and that will give us this equation, the equation for this line right here. All right, so I worked through this here. I've substituted the 2 in for the y, the 1/6 for our slope, because that's what our slope was up here, 3/2 for our x, and we don't know what b is. I went ahead and just multiplied numerators and denominators. We could have canceled here and said 3 goes into here one time and 3 goes into here twice, and we would have come up with 1/4 right there. We get 2 equals 1/4 plus b. Subtracting the 1/4 from both sides, we end up with 2 minus 1/4, but 2 is 8/4 minus 1/4 would be 7/4. So now we're going to take these two equations and we want to know where they intersect. We're looking for the center right there, and that's where those two lines are going to intersect. That is the center. So now what we're going to do is we're going to take these two equations, and from earlier classes, you should know that by setting those equal to each other, we can find the point of intersection. All right, so now what we're going to do is just to do a little bit of algebra here. We're going to bring our x's together, so I'm going to add 3/2 to both sides. Excuse me, 3/2 x. And I brought it to this side so my x's would be positive, which means I need to move this 7/4 to the other side. I'm going to do that by subtracting. So to add these, I need to make sure I have a common denominator. Well, the common denominator would be 6 for both of those. So 13/4 minus 7/4, they already have a common denominator, so that's 6/4. I could simplify that, but I'm just going to wait until the end. Common denominator for 6 and 2, though, would be 6, so I need to multiply this by 3. So this would be 9/6. That's a terrible 6. Sorry about that. Let's try that again. 9/6. But I need to move this to the other side, so I can divide by 9/6 or I can multiply. All right, did you catch my mistake? I forgot to add this 1/6 to this. One 6 plus 9/6 would give me 10/6, not 9/6. So I'm going to multiply this by 6 over 10. And whatever I do to this side, I have to do to this side. Now I could do some simplification because 2 will go into both 10 and 6 and 2 will go into both 6 and 4. Or I could just do the multiplication, which would give me 36 over 40. But that's going to simplify to 9/10. And that is what x is equal to. Now remember, once we find x, we have to go back in and plug it into one of those two equations and find y. It doesn't matter which one you choose. I'm going to choose the -3/2 x, and I'm going to put 9/10 in for that. So I have -3/2 times that 9/10, and then add to that 13/4, and that's going to equal my y. Well, this is going to give me a -27/20, and then 13/4. 13/4 would be the same as 65/20 because I would multiply both top and bottom by 5. So that would be 65/20, so that it had the same denominator. But if I combine -27 and +65, that gives me 38 over 20, which when I simplify that gives me 19/10. So now I have my center of 9/10 and 19/10, but I need to find the radius to be able to write that. And how would I find the radius? Well, the radius is the distance, the length of the radius is the distance from the center to any one of the points. And it will be the same for any point. So I chose the point 1, 5, and here's my center, 9/10, 19/10. And I simply substitute those things into the distance equation. So the distance equation is x1 minus x2 quantity squared plus y1 minus y2 quantity squared, and that's all under the square root. 1 minus 9/10 is 1/10. 5 minus 19/10 is 50/10, which is 31/10, and then I'm going to square each of those things. Squaring 1, I get 1/10, squaring 1/10, I get 1/100th, and squaring 31/10, I get 96 over 100ths. Combining those things, I get 962 over 100, or if I simplify the denominator, I get the square root of 962 over 10. So now I have the radius and the center, and I simply need to put those into our standard form of the equation. My center is 9/10, 19/10. My radius is the square root of 962 over 10. My radius squared equals x minus h squared plus y minus k squared. And remember, this hk here is my center. So here's my radius squared. Here's my center, substituting in the h and the k. And this is my standard form of the equation. So that's how you find how to write the equation of a circle if you are given the 3 points.